All right, you guys, this is concentration and dilutions, lecture video 5. And we are going to begin the conversation on dilutions. But just to follow up or recap what we've talked about so far. So far, we've talked about concentrations. And you guys know that a concentration is basically the strength of a medication. All right? Strength of a medication. So the terms can be used either or, concentration or strength. All right? And so you guys know that concentrations can be expressed 3 different ways. Again, that's a ratio, which is like 1 to 2, 3 to 4, whatever the case may be. A percentage, so 45%, and it also can be expressed as a fraction. So a medication that's 250 milligrams per 5 milliliters, all right? These are examples of how concentrations can be expressed as. In addition to its expression, concentration come 3 ways. There's 3 types of concentrations. All right. One is weight to weight, which has the units grams per grams. You have weight to volume, which has the units grams per milliliter. And you also have volume to volume, which has the units milliliter per milliliter. And so overall, what that means is that a medication could be 50%. All right. Well, 50% is how the concentration is expressed as, but in detail, what type of concentration is it? Well, if it's a cream, then that 50% will be considered a weight to weight. So it's 50 grams of active ingredient and 50 grams of total. All right. Well, why is this important when we start talking about dilutions? All right. So when we start talking about dilutions, you need to know, or when we start talking about allegations, concentrations and how concentrations are expressed and the types of concentrations are important, because when you get a problem, you need to be able to look at that problem and identify which number is the concentration. All right. So let's talk about dilutions. And when it comes to dilutions is basically taking a stock medication, in parentheses, I'm going to put highest concentration. All right. So with the dilution, you're taking a stock medication that has the highest concentration, and you're diluting the medication to a desired concentration. So for instance, I'll give you guys an example. The doctor gives you a prescription, all right, for alcohol 45%. Well, you guys know that alcohol comes in a 90% and a 70%, but it doesn't come in a 45%. So what you would have to do is take whatever percentage of alcohol that you have on the shelf, and let's just say that you have 70%. It is your responsibility to lower the 70% to 45%. But you're going to do that by using the dilution formula. And with that dilution formula, that dilution formula is C1 times Q1 equals C2 times Q2. Well, what does this mean? Well, C1 equals the stock concentration, what you have in stock, which means it's always going to be the highest concentration in the problem. All right? The Q1 is the stock quantity, meaning how much quantity of the stock medication do you need to get to that desired concentration. C2 is your desired concentration. It's going to be the lowest concentration. Because again, what is the definition of dilution? You're taking a high concentration and you're lowering the concentration to the desired of the prescription. And your Q2 is your what? Your desired quantity. So when it comes to dilutions, and when you're solving for dilutions, you automatically know that when you're looking at your problem, you're going to have at least 3 values known, and you're going to be missing at least 1 value. So when solving dilutions, you're going to have at least 3 known values. All right. Your unknown value will be an X. So I know you guys are thinking, well, Miss K, how in the world am I going to solve a problem like that? What does a dilution problem look like? Well, let's go ahead and let's try. Let's try to solve a problem based off of what I've told you so far. All right. So again, with dilutions, I'm going to put here at the top your formula for your dilution. And I'm going to show you step by step on how to solve these problems. All right. So let's keep in mind that for a dilution formula, your dilution formula is C1 times Q1 equals C2 times Q2. All right. So I want you guys to turn to let's look at number 8 on page 531. Number 8. And this reads that a boric acid solution is 1 to 10 strength. How many milliliters of 1 to 10 boric acid solution would be necessary to prepare 100 milliliters of a 5% solution? Okay? So, we can solve this without a problem. I'm going to erase the bottom of the sheet here so we can have enough room to solve. So let's go ahead and identify some components. So like we've done before, you know, I always like for you guys to ask yourself, what type of problem is this? Is it a concentration? Is it a dilution? Or is it an allegation? If it's a concentration problem, you're only going to be given one concentration, whether it's expressed as a ratio, a fraction, or a percentage. If it is a dilution problem, you're going to be given two concentrations. All right, two different concentrations. That's the key. All right. And if it's a allegation, you're going to be given three different concentrations. All right. So as I read this problem, it says a boric acid solution is 1 to 10. All right. So that is what? This is a concentration. So I'm going to circle this here and identify that this is a concentration. All right. It says how many milliliters of 1 to 10 solution? Well, let me stop here. This 1 to 10 solution is a concentration, but again, it's not different from the previous concentration. It's the same concentration. So it's just repeating itself. So it says how many milliliters of the 1 to 10 solution will be necessary to prepare 100 milliliters of a 5%. So here, this is a concentration as well. It's a different concentration. So you know that off the bat, this is a dilution problem because you have two different concentrations listed within this problem. So because it's a dilution problem, your next step is to identify the components within the dilution formula. So you're going to identify your components. So you're going to identify your C1, your Q1, your C2, and your Q2. So your C1 is considered your desired your stock. Your C1 is considered your stock concentration, correct? So your stock concentration is your C1. So, and it's always going to be the highest concentration. So in this particular problem, this 1 to 10, if I rephrase that or rewrite it as a percentage, which that is the only way for you to solve this problem, you cannot multiply ratios to whole numbers. It's just not going to work. So if my C1 is this 1 to 10, I'm going to go ahead and change it to a percent. So you're going to change this 1 to 10 to a fraction and multiply it by 100. That gives you 10%. This is your C1. You automatically know that your C2 is the 5% because it's the lowest concentration. All right. Your Q1 is the stock quantity. How much of the 10%, this 1 to 10, all right, this 10%, how much of it is needed to make 100 milliliters of a 5%? You don't know. So this is what you're looking for. So your Q1 is your X. Your Q2 is the 100 milliliters. Because in the problem, if you reread the problem, it says how many milliliters of 1 to 10 solution will be necessary to prepare 100 milliliters of a 5%. All right. So that 100 milliliters of a 5% is your Q2. So now you can solve the problem where you take Q1, which is, or your C1, which is 10, times your Q1, which is X, equals your C2, which is 5, times your Q2, which is 100. So that's 10X equals what? 500. You're going to divide 10 on both sides, and X equals 50 milliliters. You know that it's milliliters because the units that you're units that you're looking for, or the component that you're looking for, is quantity. Your quantity is going to be in milliliters, all right, because your other quantity is in milliliters. So your answer for number 8 is 50 milliliters. Alrighty, we are going to stop there for now, and we'll pick back up in the next video.